Notice that the altitude divides the triangle into three similar triangles. If we said that this was angle X, angle Y would be the complement to angle X. Angle X plus angle Y would equal 90 degrees. If this is angle X and this is 90, then this has to be angle Y up here. If this is 90 and this is angle Y, then this angle up here has to be angle X. That proves that by angle, that triangle ABD is similar to triangle ADC is similar to triangle ABC, like the larger triangle. The altitude of a right angle triangle divides the triangle into three similar triangles. We have to define something called an orthogonal projection, OP, used to abbreviate orthogonal projection. The orthogonal projection of AB onto the hypotenuse is BD. AB onto BC would be BD. BD compared to AD, the short leg compared to the long leg of this small triangle, BD over AD. In terms of this triangle, I'm looking at three different triangles. So the tiny one, ABD, then a medium triangle, ADC, then we're going to look at the large triangle, ABC. If we're comparing the small leg of this small triangle to the big leg of this triangle, AD, we can look at the medium triangle. So the small leg would be AD and the big leg would be DC. And if we were looking at the larger triangle, the small leg would be AB and the big leg would be AC. We could cross multiply and get AD squared. We end up with AD squared is equal to BD times CD. AD squared, that's the altitude squared, is equal to BD, which is the small orthogonal projection, or the orthogonal projection of AB onto BC, times CD, which is the large orthogonal projection, or the orthogonal projection of the larger leg onto the hypotenuse. BD would be the orthogonal projection of the small leg, and CD would be the orthogonal projection of the big leg. Our rule becomes the altitude squared is equal to the orthogonal projection of the small leg times the orthogonal projection of the big leg. And then I want to look at the small leg compared to the hypotenuse. In this case would be BD compared to AB is equal to, in the medium triangle, the small leg would be AD and the hypotenuse would be AC, so AD over AC. Then in the larger triangle, the small leg would be AB and the hypotenuse would be BC. Cross multiply this way, so I get AB squared. That gives me AB squared is equal to BD times BC. A to B squared is the small leg squared is equal to BD, the orthogonal projection of the small leg, times the hypotenuse. Then if we looked at the big leg compared to the hypotenuse in the small triangle, the big leg would be the altitude AD over the hypotenuse AB. Then in the medium-sized triangle, the big leg would be CD and the hypotenuse would be AC. CD over AC. Then in the large triangle, we're looking at the big leg, which would be AC over the hypotenuse BC. Cross multiply here, so I get AC squared. And then the BC multiplies the CD. That gives me AC squared is equal to CD times BC, which is AC is the big leg squared is equal to the orthogonal projection of the big leg, CD, times BC, the whole hypotenuse, times the hypotenuse. Then if we took this again, the same proportions, then cross multiplied it this way. AB times AC is BC times AD. That gives us another formula with altitude. AD is altitude times BC times hypotenuse is AB, the small leg, times AC, the big leg. We end up with the perpendiculars. These two perpendicular sides, the short leg times the big leg, is equal to the other perpendiculars, the altitude, which is perpendicular to the hypotenuse. Altitude times hypotenuse is small leg times big leg. These are our four rules that we use to solve questions with altitudes in right-angled triangles. Let's have a look at an example. Here's our four rules rewritten. We need to find out what x is. This is the small leg. The small leg squared is equal to the orthogonal projection of the small leg, that's this a to p, which is 6, times the hypotenuse, which is 6 added to x minus 6. The small leg is AC squared is equal to the orthogonal projection of the small leg AP times the whole hypotenuse AB. Fill in what we know. AC is 10 squared, that's 100, is equal to AP is 6 times 6 added to x minus 6, which gives us x. We have 100 is equal to 6x, and divide both sides by 6, that gives us 16.6 repeating is x. Let's try another one. If we want to find x, x would be the small leg. If I use this one again, small leg squared is equal to the orthogonal projection of the small leg, that's the 2.87, times the whole hypotenuse, which is just adding these two together. The small leg is d to e, so d to e squared is equal to the orthogonal projection of the small leg onto the hypotenuse, is d to g, times d to f. Fill in what we know. D to e is x, x squared is equal to d to g is 2.87, times the whole hypotenuse is 2.87 plus 5.04. That gives us x squared is equal to 2.87 times 7.91, which is 22.7017. Take the square root. That gives us x is equal to 4.7646 centimeters. Then to find y, this is the altitude. I'm going to use the altitude squared formula. Altitude squared is equal to the orthogonal projection of the small leg times the orthogonal projection of the big leg. This is the orthogonal projection of the small leg, and 5.04 is the orthogonal projection of the big leg. E to g is the altitude. Squared is equal to d to g times g to f. That means y squared is equal to 2.87 times 5.04, which is 14.4648. Take the square root of both sides. Y is equal to 3.8033. Then to find z, big leg squared, is equal to the orthogonal projection of the big leg times the hypotenuse, which is EF squared is equal to FG times DF, F to G, the orthogonal projection of the big leg onto the hypotenuse, times the whole hypotenuse, which is 5.04 times 7.91, which is 39.8664. Take the square root of both sides. Z is equal to 6.314.